Hello and welcome to 7-3. Today we're going to be studying proportions. Now proportions really come in handy when we're trying to figure out miles per hour, how long it's going to take us to get somewhere. So we'll just kind of start our little introduction to proportions here. I put this little picture here because I thought it showed nicely that our two numerators have to be related and then our two denominators have to be related. That will make more sense on the next couple slides. So let's get started. Have you ever heard water called H2O? H2O is the scientific formula for water. One molecule of water contains two hydrogen atoms, or H2, and one oxygen atom, or just O. When we bond together, they make H2O. No matter how many molecules of water you have, hydrogen and oxygen will always be in the ratio of 2 to 1. So then we have this nice table here. Water molecules, if there's one water molecule, our numerator will be the hydrogen atom, and our denominator will be the oxygen atom. So for 2 hydrogens for 1 oxygen, 4 hydrogens for 2 oxygen if we have 2 molecules, and so on. So a proportion is an equation, that means it has an equal sign, that shows two equivalent ratios. So if I were to draw a proportion using the table above, I could say one of my proportions would be 2 hydrogen to 1 oxygen would be equal to 4 hydrogen to 2 oxygen, right? If I reduced 4 over 2, I'd get 2 over 1. So that is what our proportion would be. Again, it has to have an equal sign, and all sentences that have an equal sign are called an equation. So let's try some examples here. So first, write the ratio of circles to squares. So our ratio could be written as 2 to 4, or 2 to 4, or 2 to 4. And next, separate the triangles and circles into 2 equal groups. So in this, I would say there are now we're at the ratio of circles to squares in each group. So I would have 1 circle to 2 squares, or 1 to 2, or 1 to 2. Finally, writing a proportion using the 2 ratios you found. That means using the first ratio and the second ratio. So if I were to make a proportion for that, I would do 2 to 4 equals 1 to 2. And they are equivalent ratios. Now this is kind of our basic understanding, just kind of our introduction. Now let's take it a little step farther. To see if a proportion is correct, you can use cross products. Now cross is just like what it sounds like. We're going to go cross. And products means multiplying. Okay, so if I wanted to see is 4 to 6 proportional to 16 to 24, I would use my cross products to see if they are equivalent fractions, basically is what I'm doing. So 6 times 16 and 4 times 24. They should equal the same number if we were to say our proportion is correct. So let's figure that out. Alright, so yep, 96 does equal 96, so yes, this is a correct proportion. Let's do some more. Use cross products to find the missing value. Okay, so this is where we'll see it a lot. So what I would do, my first step, is to write it out. 3 times 16 should equal 4 times n. Okay, so let's figure out what is 3 times 16. So 3 times 16 is 48 equals 4n. Because here again I'm just doing 4 times n, and I don't need to write my multiplication sign down. I can just write 4n. Okay, so now we've seen this kind of thing before. I have to divide both sides by 4 because I'm undoing the multiplication that is between 4 and n. So if I divide both sides by 4, those would cross off, and I'd be left with n equals, and 48 divided by 4 is 12. So to make these proportionate 3/4 and n over 16, n would be 12. All right, let's try another using cross products. Oh, another 4n. Okay, 4n equals 1 times 12 would be 12. All I'm doing is I'm multiplying going across, going diagonally really. So then I would divide by 4, divide by 4. My 4's would cross out. I'm left with n equals 3. So we're just finding the missing value. Now here we'll do it again. It does not matter which side is on the equal side. It doesn't matter which side you put them on the equal side. They will all be the same. So I could start doing 18n, or I could start doing 3 times 6. So I'll do 3 times 6, which is 18, equals 18n. Divide by 18, divide by 18, and I would get n equals 1. Okay, and here it looks like I should write n times 18, n 18, but we talked about before we have that commutative property of multiplication, so I can switch 18 and n around. And we always talk about when we have a coefficient, which is the number before a variable. If I have x, we're always going to put the number before the variable. Okay, let's say we have one more slide to check out here. The label of the bottle of pet vitamins. Oh, this is a good problem. Okay. The label of the bottle of pet vitamins shows recommended dosages. So, for example, we have an adult dog. They should use 1 teaspoon for every 20 pounds of body weight. So if the dog weighs 40 pounds, we would need to use 2 teaspoons, and so on. But what if they don't weigh the exact amount? We don't want to give our dog too much that it could hurt them, or too little that it doesn't do its job. So we have to figure out the exact amount of medicine we're going to give to our dog, or puppies, or cats. So what dosage would you give an adult dog that weighs 15 pounds? Okay, so we can't even give him 1 full teaspoon because he's not 20 pounds yet. So we have to set up a proportion so that we can get an exact amount that we would need. So I know that I need to give an adult dog 1 teaspoon for every 20 pounds. Okay, and this is where this really comes in handy. We know the information that the dog weighs 15 pounds. Okay, so I need my relation. Pounds is on the bottom here, so I need my pounds to be on in the denominator over here too. We know our dog is 15 pounds. Okay, and what we don't know, our variable, is right here. We don't know how much medicine to give him. As in our numerator over here, we put the medicine on top, pounds on bottom, so we don't know how much medicine. Now we just do exactly what we did. We use our cross products to find our missing value. So here I would say 1 times 15 is 15 equals 20 times x, or 20x. Okay, we're going to get a fraction or a decimal here. So I would divide by 20, divide by 20. So x equals, and now when we're talking food measurements, that sort of thing, I know that I've heard 1/4 of a cup, 2/3 of a cup. I haven't heard 33/100ths of a cup. So I know that I'm going to write my answer in fractions. Okay, so if I already have 15/20ths, I could just divide them both by 5, both the numerator and denominator by 5, and I would get 3/4. So if I know x is 3/4, I know that's how much I need to give him. So what dosage would you give an adult dog that weighs 15 pounds? So when I wrote my answer, I would give him 3/4 of a teaspoon and that's how much my 15-pound dog should get. So that's kind of where we're taking all of this. They will always give you one ratio, and then usually you'll have to figure out what the other missing piece would be. Now I'm stopping here. Again, we'll practice lots of these problems tomorrow in class. So if you have questions, make sure you write them in the question spot. But if you don't, we can just come in. We'll try a few. If you need help, I'm always here to help. Just make sure that you're advocating for yourself and asking for help when you need it. Anyways, thank you for watching, and we'll see you tomorrow.